The process is called refining. It's way cooler and more complicated than you might think. First up, crude oil arrives at the refinery in giant ships' pipelines. It's a mess, packed with everything from heavy tar-like gas.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons.
Hello, dear followers. This is Teacher Alan once again, streaming in live from Pro Online Studios. I'm back as usual to simplify chemistry and to verify my usual statement of sciences we have made the simplest. I'm here to deal with a simple context, and I want us to go through some process of purification of crude oil. We all know that in Uganda, oil was discovered and they actually started mining it around the Bunyolo areas. I'm here to take you through the part of the crude oil that falls under section B, and that is strictly part 1 of chemistry, paper 1. Members, remember this part has a format of a response they expect a learner to present. A learner, to remind ourselves, a learner has to state the raw materials, a learner is expected to give the process of production, and we know what is expected in the process of production. We know that very well. A learner is expected to as well give the social benefits for the process of production. A learner is also expected to give the side effects the side effects of the process of production and their mitigations. Members, the social benefits and the side effects are of the process of production. I want us to go through the process of purification of crude oil. This is a simple process that anyone should have attempted if one gets across it in a paper. The process of the raw materials for this process of purification of crude oil, it is crude oil itself. So what they do, remember, in most cases, the oil is always, is most times found in areas of sun and water. Like the one we have, it is on a water body, the one we have here. So the purification process involves one, separation of the crude oil from its impurities. The most common impurities of crude oil is sand and water. All these impurities are simply removed. For example, the sand is removed by simple filtration, and the water is removed from the crude oil using separating funnels, since the water and the crude oil have different densities. The second, this oil is, after purifying it or removing the impurities, the crude oil that is free from water and sand is pumped into refineries. The refinery has a heating chamber where it is fed with very hot air at very high temperatures of over 500 degrees Celsius. And it also has what we call the fractionating um, chamber or column. The fractionating column has chambers at different temperatures. So the crude oil that is free from the impurities is heated and in a refinery by hot air, and its vapor is rapidly pumped into what we call the fractionating column. The fractionating column has chambers that are at different temperatures, and the chambers at the bottom are hotter than the chambers at the top. So the chambers at the top are cooler and the chambers at the bottom are hot. Members, we have not to forget that the crude oil is made up of components. It is one of the natural mixtures we have. It has components. We shall find that from it we obtain gases, natural gases. From it we shall obtain the kerosene, the petrol. We shall find the diesel, butane, and others. So how are these ones separated from each other? In the process, we call it refining. So members, as the vapor or the crude oil vapor is fed into the fractionating column, whose bottom is hotter than the top, these gaseous or vapor form of this petroleum component or the crude oil component will go on cooling or condensing to liquid forms at different chambers basing on the boiling points. Because we know if we take an example of water, water boils at 100 degrees Celsius, meaning this is the temperature at which, the liquid water starts to turn into vapor. So the temperature that is above 100 and above, the water is in vapor form. And then the water is in liquid form if it falls to temperatures below this 100. So this means that if the bottom part of the fractionating column is at a high temperature, it means for the components of crude oil that boil at very high temperatures, there will be liquids or they will turn to liquids if they as they move up, they will go on cooling such that those ones of very high boiling points will go on condensing earlier than those of low boiling points. So if one of the components of crude oil cools or condenses or turns to a liquid at 400 degrees Celsius, it means for the temperature that is below this component will be a liquid. And the component that boils at a lower temperature, for example, the one that boils at 150 degrees Celsius, it will remain a vapor so long as it is still in the lower part of the fractionating column. Why? Because the lower part or the bottom part of the fractionating column is at a temperature that is above the boiling point of that component. So it will keep as a vapor. But as soon as it starts moving above the fractionating column, the temperature, we are seeing the temperature of the column is going on lowering, meaning that the temperature will lower as the components of the vapor form of the crude oil move up. So that is simply the summary of the refining process of crude oil. So what we have, we shall have the raw materials. We've said the raw materials for this is crude oil.
All right, let's break down how the sticky black goo we call crude oil turns into the gasoline diesel plastics we use every day. The process is called refining. It's way cooler and more complicated than you might think. First up, crude oil arrives at the refinery in giant ships' pipelines. It's a mess, packed with everything from heavy tar-like gases. Step 1 is heating. The oil is pumped into a furnace cranked up to about 350 degrees Celsius. Yeah, that's seriously hot. Next, it hits the distillation tower, which is basically a giant vertical column. Inside, the oil vaporizes the different parts separate, but really it's all about boiling points. The lightest stuff, like gasoline, floats to the top. Middle stuff, like diesel kerosene, collects in the center. Heavy stuff, like lubricants asphalt, settles near the bottom. But we're not done yet. Some of those heavy leftovers get cracked in another reactor, breaking them into smaller, more useful molecules. This is called cracking. It helps make even more gasoline jet fuel. After all that, the products go through more purification, like removing sulfur to make fuels cleaner. Finally, everything's blended, tested, and sent out to power cars, planes, and just about everything else. It's messy, high-tech, pretty mind-blowing how we turn crude oil into the stuff our world runs on. Next time you fill up your tank, you'll know just how much science went into it.
The process of production, we know what they mark. We are going to look at it. We've said that first of all, the crude oil is separated first from its impurities such as water, and sand, and then fed into a refinery. In a refinery, the crude oil is heated at very high temperatures. Usually above 500 degrees Celsius using hot air. As we heat it, we are going to find that this crude oil is going to be converted to vapor. So it is this vapor that we feed into or rapidly pump into the fractionating column. So the vaporized crude oil is then rapidly pumped into a fractionating column whose bottom is hotter than the top columns, which are cooler. So the column, like I've just explained, the chambers that are below, or the columns that are below, are hotter than the chambers that are above. Each chamber is connected, has an outlet pipe that carries away the condensed crude oil component. And each chamber has its own temperature. So it's what we are noting. The fractionating column has chambers at different where the components of the vapor of the vaporized crude oil condense to liquids. Members, we are looking at each chamber. We all know how a refinery looks like. A fractionating column. We've ever seen it. It has an upper outlet where the ones that remain as vapors or gaseous form escape from. It has, let's say, the first chamber connected to an outlet pipe. Members, it is where each of these chambers have different temperatures. If this one is at 100, let's say 120 degrees Celsius, this one will be at a temperature that is above this one. Because we say the chambers have, the chambers at the bottom are hotter than the chambers at the top. And at each chamber, there is a component that cools there, basing on its boiling point. So it's what I'm noting now. The vaporized components condense separately in chambers to liquids, starting with those with the highest boiling points. We know, such as the bitumen, will condense fast because it has a high boiling point, meaning that as you move up the chamber, the temperature is going to go on lowering, meaning that that substance or that component, we said if the boiling point of water is 100, any drop any drop in temperature, the substance will be turned back into its liquid form. And any increase in temperature, it will keep this substance in its vapor form, meaning that this temperature is above its boiling point. It is above the specified temperature at which that substance just turns to vapor. And the more you increase the temperature, the more the particles making up this substance become free. I think I'm clear. So we shall be collecting those ones with the highest boiling point as liquids first, and then later those ones with the lower boiling points. So these components will be tapped off through the outlet pipes to reservoir tanks, where they are temporarily stored before they are transported or distributed to wherever they are to be used. So I'm not going to try to that, but I think you can pause, you can rewind the video, you can forward it to see what you want. You can even share it to your friends. Don't forget to subscribe, share it with your friends. Don't forget to like the video if you really like what we do. And members, I'm not going to give the social benefit. I remember we talked about them. The key one is this purification process or refining process of crude oil is a source of employment opportunities. We know that many people are employed there. And what is the outcome of being employed? These people earn salaries. What does the salary do? The salaries, they use the salaries to improve their standards of living. Members, the side effects we can talk of, there is also, we looked at process of production, and we are seeing there is a process of heating. Remember, this is a liquid. The heating will result into formation of waste gases. These waste gases sometimes escape to the atmosphere, most of which are greenhouse gases, which destroy the ozone layer, keeping heat on the Earth's surface, resulting into global warming and usually desertification and famine. So members, we give the side effect of the process of production. The social benefit we give is of process of production, not the product we are manufacturing or purifying. The mitigation for that side effect, we can talk of installing catalytic converters on the outlet pipes, just to neutralize the effects of these gases. Remember, we have more videos that we recorded about this kind of information on chemistry paper 1, section B, part 1. We know how to mark what we mark. You look for the process of production. When you look at it, you check for the vessel, and we said the vessel is the container where the raw material is converted into products. You look for the process of product, the chemical processes involved. There are many here. There is this one of separating the crude oil from its impurities. That is a chemical process. We look for the step of converting the raw materials to the desired products, the CDP. The logical flow of information should be also looked at in the purification part. So members, if you don't mind, I beg to end here. This is Teacher Alan, representing Muto Online, as always. Thank you for watching.